Hello, this is Kyle. Today we'll be working on a question from the textbook. Question 8 on page 283. Question says, the value of an investment is modeled by A of t equals A naught times e to the power 0.065 t, where A is the amount the investment is worth after t years, and A naught is the initial amount invested. A key part of this question is the equation itself. We can see that this is an exponential function because of the letter e and the fact that our t is in the exponent. So, one more time, the value of an investment is modeled by A of t equals A naught e to the power 0.065 t, where A is the amount the investment is worth after t years, and A naught is the initial amount invested. Part A of this problem says, if the initial investment was $3,000, what is the value of the investment after 2 years, 5 years, and 25 years? In order to solve this problem, I've outlined a couple steps that we could use for each part in this question. The first step is to write the equation. This gives us a basic guideline from where to start. Second step is to substitute the number of years for t. I've substituted 2 for t in this part. Third step is to substitute the initial value for A naught. The question tells us that the initial value is $3,000, and so we will substitute 3,000. For step 4, we will simply solve for the remaining variable, A. After simplifying the exponent, we simply substitute our numbers into the calculator and receive an answer of 3,416.485. This means that after 2 years, the value of our investment is about $3,400. For 5 years, we simply follow the same steps. We'll write the equation, substitute number of years for t, and then substitute the initial value for A naught. We've substituted 5 for t and 3,000 for A naught. After simplifying our exponent once again and plugging the numbers into our calculator, get an answer of 4,152.092. This means that after 5 years, the value of the investment has increased to about $4,100. For 25 years, once again we will follow the same instructions. We'll write down the equation for a basic guideline, and then substitute 25 for t and 3,000 for A naught, the initial value. After simplifying our exponent and substituting the numbers into our calculator, we get an answer of 15,235.257. Now, all we have to do is write our therefore statements. For part 1, therefore, the value after 2 years is about $3,416.50. For part 2, the value after 5 years is about $4,152. And for part 3, the value after 25 years is about $15,235. Part B of our question reads, how long will it take for this investment to double in value? In order to complete this step, I have outlined 4 new steps that we can take in order to solve this question. First step is to again write the equation for a guideline. Number 2, we'll substitute A for double the initial investment, since that was what the question was asking for. Part 3, we'll substitute A naught for the initial investment, again, same as part A, and 4, we'll solve for t. This process is different from the first one, because here we're solving for t, whereas in part A, we were given t and asked to solve for A. This question, we're given A and asked to solve for t. We start off the same way by writing the equation. First, we'll substitute 6,000 for A. We do 6,000 because that's double the initial value, 3,000. After writing our initial equation and substituting 6,000 for A, all we have to do is divide by 3,000 to remove the A naught term from the E, we're left with 2 equals e to the power 0.065t. We then take the ln of both sides in order to remove the e, and then we divide by 0.065 in order to isolate t. We come to the answer 10.66 equals t, which means that it will take about 10.7 years for the investment to double in value. Now that we've completed that, we can continue on to Part C. Part C says, at what rate is the investment growing at the time when its value has doubled? This question is very important because it's the first time we see a rate. This means that we have a new set of instructions in order to solve this problem. Our first one is to write the equation. Then we need to differentiate the function. We do this because we need to solve for the slope of the function, which would be the rate. After differentiating, we substitute t for the time solved for from Part B, which is 10.66 years. Number 4, we'll substitute a0 for the initial investment. And then 5, we'll solve for a prime, which will give us the rate at which the investment is changing. To differentiate an exponential function, all we do is keep the original function the same, but then we multiply by the derivative of the exponent, in this case 0.065. We can bring this term to the front of the equation in order to keep proper form. Once we have the derivative, we can substitute 3000 for a0, or our initial value, and t for 10.66, which was the value we calculated from Part B. After simplifying the coefficient to 195 and the exponent to 0.6929, we can solve for a prime. We use our calculator and get the answer 389.90. We finish off this question with our therefore statement. Therefore, the investment is increasing at a rate of about $389.9 per year at the time when its value has doubled. So this means at exactly 10.66 years, the investment is increasing at a rate of $389 per year. Now that we have completed all parts of the question, we can see how this question would be very good for a grade 12 class. We have a very difficult function with the exponent and base e. We also have the idea of the derivative from Part C, which tells us about the rate at which the function is growing. But how would we apply this knowledge in real life? The key word here is the investment. This means that this would be applicable from a business standpoint. Whether you are the person making the investment or the financial advisor controlling what happens with the investment, you need to know how much money is going through. With the model here and the function, we can see exactly how much money the investment would be worth after any given amount of time, and we can also see the rate at which the investment is changing. If there is a point in time when the investment is decreasing in value, it would be important to know from both the owner of the investment's perspective and the perspective of the financial advisor. I'm Kyle, and thanks for watching.